Hello, this is Diagnostic 1 from Fast Track. We'll start with question 2 because question 2 is easier. Okay, so we're just asked to simplify this. So the way to simplify it is to factorize. Okay, so what's the highest common factor between these two? Highest common factor is 7 to the power a third, and then you see what's left over. So from the second term, 1 is left over, and from the first term, well, we have 7 to the 7 over 3, and we've just divided by 7 to the third, so we're left with 7 squared. So that is 7 squared, and so the final answer is just so equal to 7 to the third, and that 7 squared is 49. 49 take away 1 is 48, so write the expression as 48 cube root of 7. Okay, that's pretty straightforward. Now question 1 is less straightforward and requires some thought, and the answer, not the answer, how to go about it may not be immediately obvious, but that doesn't matter. So what we need to do is start off from what we know. So here clearly this question is to do with indices, so we might need to review the rules of indices, and if we do that, we'll hopefully realize that the rules that we may need to use are these ones. And another thing we need to hopefully see is, in order to simplify this, we may need to break up the 6 and the 12 and the 8 and the 9, so using their prime factors. So let's start. The 6 is 2 times 3. The 12 is 2 times 2 times 3. Denominator, the 8 is 2 times 2 times 2. The 12 is 3 times 3. And now we use the first of these rules to split. So the numerator is 2 to the r plus s times 3 to the r plus s, 2 to the r minus s, 2 to the r minus s, 3 to the r minus s. The denominator is 2 to the r, 2 to the r, 2 to the r, 3 to the r plus 2s, and also 3 to the r plus 2s. Let's now use the second of these to put the 2's together and the 3's together. So the numerator, well, look at the powers of 2. So we have an r here, and another r, and another r, another r. So we've got 4 r's. Not 4 r's, sorry. 3 r's, because the last one, this is a power of 3, obviously. And how many s's? So we've got an s there, minus s, and minus s. So altogether we have minus 1s, times by 3 to the power, an r here, an r there, so it's 2r. S is, we've got a plus s and minus s, they cancel, so that's the numerator done. The denominator, 2 to the power what? So we've got 1r, 2r, 3 r's, so 3r. The powers of 3, we've got an r and an r, so 2r. 2s makes it plus 4s. Now, using the third of our rules, the expression becomes, well, powers of 2, we've got 3r minus s. We're going to take away 3r, so we're going to be just left with minus s. The powers of 3, we've got 2r, take away 2r plus 4s, So the r's cancel, we're left with minus 4s. So we've simplified as much as we can. Now let's read the question again. The question says, we want this expression to be an integer, and we're asked, when is this going to be an integer? Which of these conditions must be true? Go back to our expression. If this is going to be an integer, we need the powers to be positive, because if the powers were negative, then what happens? We would get a fraction. So for example, if it was, say, minus 2 to the power minus 3, this would be 1 over 8. Okay, so we need the powers to be positive, and so we need minus 4s to be greater than or equal to 0, and therefore, if that is to be true, then s must be less than or equal to 0. And that, hopefully, is one of the solutions, and there it is. Yeah, so the answer is B.